friends, welcome back to my YouTube channel. Friends, today I am going to cover network load balancer. So if you follow me, we are working on load balancer task, and you might have seen my previous lecture, so which are covering classic load balancer and application load balancer. And this time we will talk about network load balancer. So as you can see, I am on AWS console, and if you scroll to the EC2 services, you can see under load balancer. I'll show you once you go to EC2. Just scroll down, and to your left side you can see under load balancing, it's a load balancer. So here this is the button from where we can launch the load balancers. So if you click, so right now I do not have any load balancer for Mumbai region. Okay, if you click on this button, you can see these are the various types, so we can choose the types as per our the requirement. And as we discussed last time, classic load balancer is something that is going to be stopped working, or Amazon is going to stop servicing classic load balancer after few days. Okay, so please take a note of this. So there is a note for this whatever we are going to discuss. Okay, so basically just to refresh, what is the load balancing? As we can see, elastic load balancing, which is also called as EFD, that automatically distributes the incoming traffic across multiple targets. So the target might be, it can be EC2 instances or containers or IP addresses, and that can be in one or more availability zones. Again, if you are not sure about availability zone, just check out my sessions on what is availability zones and what is data center, all those things, so you will get to know. So basically, what is this load balancer? It does, it actually monitors the health of its registered targets and routes traffic only to the healthy targets. So as we had seen last time, say when I stop one of the EC2 instance, so it will start sending the traffic to that particular target, and which are the healthy or which are the targets. So when in target we had selected EC2 instances, and the EC2 instances which are healthy up and running, so the traffic will be served by those EC2 instances that we had seen in the last time. Okay, and even as per this incoming traffic changes, so the scaling of load balancer also gets changed automatically, and it depends upon, if say there is a majority of workloads, so it will scale automatically to that. So as we discussed, so the types of load balancer are application load balancer, network load balancer, gateway, and classic load balancer. And this time we are going to talk about network load balancer. So let's see what are the components of network load balancer and how it differs from the other types. Basically, the main types of network load balancer are load balancer itself, listeners, and target groups. So basically, a load balancer, it serves as a single point of contact for the clients. So say whenever there is a load or there is a traffic, so the load balancer that is itself is responsible for balancing or distributing the incoming traffic to the multiple targets such as EC2 instances, etc. And we can add one or more listeners. So in listeners, if you remember, using listeners, we can add some rules, some ports. So we can use like port 80 or 80 for HTTP traffic, 443 for HTTPS, etc. that we can do using this listener. And what is the mainly listener does is it checks for the connection request from the client, and using the protocol. Say we use HTTP protocol, HTTPS, etc. and the port that we have configured. That is the main task of the listener. And the target group, you can see it's just a collection of these devices, or say in this case, so we can add multiple EC2 instances or containers or IP addresses in a target group, and that will be served as a end destination. So the health checks are performed on all targets registered to target group that is specified in the listener route for the load balancer that we had seen. Okay. So let me just show you. This is diagram we can refer here. See, this is the incoming data, that is in traffic is coming. It's coming to say network load balancer, and there are, say, in this diagram there are 3 EC2 instances. So you can say this is our target group, and this load is getting balanced or distributed across each EC2 instances. You can see this is here 5442. This is the port it's being used. Say in this case that EC2 instances having an application that is listening on for this port 5442. Okay, so in that case, so basically on each target, in this case what we are going to do is, see, in this case the listener will be listening on this port, and that will be configured accordingly to receive the target. So basically the network load balancer functions at the 4th layer of the open system interconnection, that is OSI model. So if you are aware of OSI model, so there are total 7 layers in the OSI, which are physical, data link, network, transport, session, presentation and application. These are the main layers, and this is the 4th. The network load balancer listens on the 4th layer. So on top we have to count. Okay, so this stands on the 4th layer of this open system OSI model. Then why we are basically using the load balancer, that is network load balancer over other types, is basically this supports, or it is due to its capable of say handling millions of requests per second. So if you are looking for extreme performance, in that case only we can go for the network load balancer. And it attempts to open a TCP connection to the selected target on the port specified in the listener configuration. Say in this example, say the target, or so the traffic is like this. Say this is the streaming data in this case. So based on this destination, there will be listener role which will be configured on this network load balancer, and there will be, so that listener role might have, say, which are the EC2, what is the target group. Say for example, this can be a target group A, just to give an example. So there will be like, which is the target group where the traffic should be routed to, what is the port. Say everything will be in the listener, which will be configured, and accordingly traffic will get routed to in that case. Okay, and we can enable an availability zone for load balancer. Elastic load balancing creates a load balancer node in the availability zone. Say here in the diagram we have just one availability zone. Okay, say, but in case say we have multiple availability zones, say this is availability zone 1, availability zone 2, etc. In that case, each zone will have a load balancer node that will be configured in that case. So load balancing node that will be configured, and the task of that will be, it will distribute the traffic across registered target in its availability zone only. So that will be, say in this case, there is, say, another availability zone is also there. In this case, there will be a load balancer node that will get auto created, and it will traffic like route the traffic to that availability zone only. Similarly, each individual load balancing node will take care of routing traffic to inside that availability zone only. That is the in that case. And say in case of cross zone load balancing, so yeah, we have not discussed this part so far, but we will be definitely covering what is this cross zone load balancing. In this case, how it works is, say for example here in this case there is a one availability zone, but if we add another availability zone, and the network load balancer will balance the route of traffic to each of this zone. Okay, so that will be cross zone, and each EC2 instance also shares, or will be each EC2 instance will contribute into that. So that is called as cross zone load balancing. So we will discuss in the upcoming session when we talk about auto scaling part in that case. So that is so far. And to increase the fault tolerance of the application, we can add multiple availability zone for load balancer and ensure that each target group has at least one target in each enabled availability zone. So basically, see, if you want to make sure that your application is fault tolerant, so what you will do basically, see in this case, your application is sitting on one availability zone which got 3 EC2 instances only. But what in case this availability zone itself goes down, your application would be fault tolerant, right? It would be available. In that case, what you will do, you can add one more availability zone, 1 or 2, and will ensure your application has the EC2 instances, that those are available in those availability zone as well, so that any of the AZ goes down, your application is still available and it will be serving. That is in case of you want fault tolerant application. And similarly, yeah, in that case what you will do, we can add multiple availability zone, that as we discussed, and ensure each target group has at least one target in each enabled availability zone that we just discussed. So yeah, this is the some of the information for the load balancing. Okay, you can go through this information that I will be just sharing in the comment section here. And we can add and remove the target groups. Say we have multiple target groups, and we can add and remove the targets. Say for example, in this case, say there are the 3 targets or 3 EC2 instances in there. Say for example, this is target group 1A, and in this case, say my first EC2 instance goes down. So we can remove it, okay, and we can replace it. In this case, there won't be any effect or any performance impact on the application. So it will still serve the traffic to other EC2 instances, unless it, and in the meanwhile what load balancer, it will keep checking whether, say if I stop this EC2 instance, EC2 is the first one, it will just try to, based on again the listener configuration, we will define there, okay, after how many seconds or how many interval it should check whether this EC2 instance is available or not, and it will mark it as unhealthy, and then it will stop the serving or sending the data or traffic to this EC2 instance. In this case, there won't be any impact to the application, okay, and it will serve as regular unless there will be another EC2 instance that will be created. So this can be created using EC2 auto scaling. That is another service which is available in Amazon, so that we can discuss in the upcoming sessions post this. So these are some of the information regarding the overview of the network load balancer. Now you will think, okay, why we should go for the network load balancer instead of classic load balancer. As we know, the classic load balancer is very basic. If you are looking for cost-effective solution, then classic load balancer is the best. And if we go up or upgrade from classic to application, so application load balancer or say network load balancer, so there will be a cost associated with that. It will be costly, but there are benefits as well. When you go for or upgrade to network load balancer, there are a bunch of benefit that it comes with that. The first of all, there is ability to handle volatile workload and scale to millions of requests per second. So the very first benefit of using or upgrading to network load balancer is extreme performance. So with network load balancer, you can ensure you are going to get extreme performance with that. Okay. Another benefit of using that is it supports the support for static IP addresses for the load balancer. We can also assign one elastic IP address per subnet enabled for the load balancer. If you have gone through this classic load balancer configuration, so that is not possible in the your classic load balancer. But with network load balancer, it supports static or elastic IP addresses, and that can be used with network load balancer. Another thing is it also supports for registering targets by IP addresses, including targets outside VPC of the load balancer. This is very important. Say when we consider so far the load balancer, the traffic can be routed, it was limited only to that VPC, that is virtual private cloud. But with network load balancer, even say we have one EC2 instance which is outside the VPC, even that can be added as a target, a recipient or destination to receive this traffic. That is one of the major benefit of using network load balancer. Then another, that is next benefit of using this network load balancer, it supports for routing requests to multiple applications on a single EC2 instance, and we can register each instance or IP address with the same target using multiple ports. Say an example, say in this diagram, say instead of this, say if this EC2 instance is serving multiple applications, okay, in that case what we can do, each application might be using different ports. Say for example, there's Apache application is running, okay, then some different applications, say some network applications running on that, and each application might be using different ports. Say for example, just to give an example, one application could use 1500 as a port, another can use 1562, or another can use 8600 as a port, which runs on the single EC2 instance. Even in that case, this support, that is network load balancer, supports requests to multiple applications on the single EC2 instance, and we can register each instance or IP address with the same target group. Okay, so that you can do. So we can register each instance or EC2 instance or IP address with same target group using multiple ports. Different ports can be used as depending on the application, and that can be used in the network load balancer. The next major benefit of using this is it supports containerized applications. So you know that there's Amazon has its own this ECS, that is cluster container service, is available in the Amazon, and using this we can, instead of this EC2 instance, we can also use containers or IP addresses as a target recipient. So that can be, you know, benefit of network load balancer. And the next benefit of this using network load balancer is it supports for monitoring the health of each service independently, as health checks are defined at the target group level, and many Amazon CloudWatch metrics are reported at the target group level. So there is also, this one is very important feature or benefit of using NLB. It supports for monitoring of the health check of each service independently. Okay, this is another benefit of using network load balancer. So friends, please let me know if you have any queries. Please go through this and you will understand. So this was just a theoretical part, because this will cost us, you know, this will be outside of the free tier and it will cost you. Hence, that's the reason I didn't cover the demo part of that. But you can go through my previous session where I had covered this demonstration part as well. So please, you know, let me know your comments on how did you find it. I hope you find it interesting. Please like, share, comment and subscribe to my channel, friends, because you know the videos like this take some efforts. So if you like it, and share and comment and subscribe, so it will be highly appreciated. And thank you so much. I wish you all a very happy learning. Okay, thank you. Bye bye.